Okay, good afternoon. Okay, am I reverberating, echoing? Okay, need to turn this off. Uh, wait. Hello. Okay, that's good now. So if you have any question, just send it via the chat box. And I've already uploaded 2 videos on the exercises. I answered some of them, and the exercises are given so that you would have an idea of what kinds of questions will come out in the second quiz, which is departmental. Still the same platform, same window, 1 to 6 p.m., same format. I mean, meaning there will be multiple choice, true or false, and some questions might ask you to submit your solutions. So that we will have 80 points in all for the quizzes and 40 points in all for the assignment. I've only given one. The assignment, I will take 20% of that, and from the quizzes, 80% to come up with your grade for Math 21. And I will be finishing all the exercises in this session, and I might not see or meet my classes tomorrow. I think all the videos I have given are enough for you to be prepared for the second quiz. So this is where actually we ended with item 1 of exercises 3B. So now we will start this session with items 3, 4, but I've just decided to just do one so that you will do the others on your own to see if you can read, if you really understood and can really do problems like this, where you have to formulate a function, a piecewise function for a given word problem. Now, don't worry about items B and C. They will not be included, where you will be asked to maximize or minimize a certain economic variable or any other mathematical quantity. That will not be included in the quiz, and we did not discuss it either. So all you have to know regarding word problems is how to be able to construct a function, a piecewise function that will model the problem. So let's start. Okay, let me read the problem. A travel agency offers an organization an all-inclusive tour for 8,000 per person. That's if not more than 100 persons join the tour. However, if there will be more than 100, then a discount will be given. It will be reduced by 50 pesos. And that's for each person in excess of 100. So if there are 102 persons, that will give 2 persons in excess, and thus giving a discount of 2 times 50, 100 pesos. If there are 10 persons in excess of 100, then that's a discount of 500 pesos for the ticket price. And so we want to generalize this problem so that we have a function that will tell us the revenue for a given number of persons that will join the tour. Let's start. There are two cases we have to tackle here. Case 1, where we have at most 100, since the price of the ticket is not affected when not more than 100 persons join. The price only changes, okay, when there are more than 100 persons. So that will be for our case 2, more than 100. So just doing it like a student would do it on a scratch paper, okay? So case 1, if not more than 100 join, then what we have is simply a ticket price of 8,000. It doesn't change. Whether you have 50 persons joining, 99 persons, 100 persons, the price per ticket will still be 8,000. So if we denote by X, X by the way represents the number of persons that will join the tour as stated there, already given there in the problem. So if the price of ticket is 8,000 and the number of persons that will join is represented by X, then we just multiply to get the revenue, which we will denote by R of X, 8,000X. So if there are 100 persons, the revenue will be 8,000. That's the ticket price times 100. So you'll generate a revenue of 800,000. So in general, if X is the number of persons, then it's 8,000X. Now for the case when X is greater than 100, things become a little complicated, since we have to determine the ticket price. The ticket price will no longer be 8,000, and the ticket price will depend on the number of persons in excess of 100. So first, we need to determine how many persons are in excess of 100. Well, simply, let's say you have 150 persons joining the tour, then you subtract 100, right? So you know that there are 50 persons in excess. In general, if you have X persons joining, then you subtract 100. This will tell us the number of persons in excess of 100. Now, to get the discount on the ticket price, you multiply that by 50. So let's say 110 persons join the tour. What is the excess? 10. How did you get 10? Subtract 100 from 110. So there are 10 persons in excess, and per person in excess, 50 peso discount. So you multiply 50 by that excess. 50 times 10, 500. So the ticket price will drop to 7,950 from an original price of 8,000. So let's do that in a more general setting where we have X persons. We know the number of persons in excess now as X minus 100. So per person, we have a 50 peso discount. So this is the total discount, okay, in the ticket price. Now that will be discounted from the original ticket price of 8,000. This is just the discount. This is not yet the ticket price. So if the original ticket price is 8,000 and this is the discount, then we subtract that to get the new ticket price, which we can denote actually by P. But since this is just formulating a model function, then there's no need to denote the price by a variable P, unlike when we're doing maximization, which is not, okay, included in this course because of the pandemic. So let's see now what will happen to the revenue function. First, we simplify this one. Oops, and just verify that this will become 5,000, 13,000 minus 50x. Okay, and again, there are X persons that will join the tour. X is the number of persons. Now, instead of the ticket price being fixed at 8,000 as in the case where there are not more than 100, this time the ticket price is variable, depends on X. So anyway, to obtain the particular revenue for a particular value of X, we multiply that ticket price by X. So we multiply the two. Okay, we get the revenue function. Okay, 13,000 minus 50x times X. Price per ticket times the number of persons who will buy a ticket. So now we have, for the revenue function, in the case of greater than 100 persons, 13,000x minus 50x squared. So now we can write down the model function for the revenue denoted by R of X, which is a piecewise function, and it's 8,000x if X is less than or equal to 100, that's case 1, and it's 13,000 quadratic now minus 50x squared if X is greater than 100. In other words, all you are asked for in problems like this is the piecewise function that will model the word problem. Is there any question on this one? Okay, none. So let's move on. I leave the other problems to you. In case you still need me, I'm available for consultation. Just email me. So we can now go to module 4. Plan to do everything in this session if there's time. Now, here I will be just doing 2. I've done an exercise like item C and D in the synchronous sessions, which I've recorded. So you can just look into that. And I will just be doing problems that involve ln and the natural, logarithmic, and exponential functions. So let's start with letter E. Now, what we are asked is the inverse, and remember the steps. Actually, some prefer to solve for x in terms of y. That's okay, and then later on interchange. But let me do it this way. Let me interchange right away. So we have x equals e to the y minus 1 plus 5, and then just solve for y. And notice that y is on one side, so we have to isolate that y on one side of the equation. So we will have x minus 5 equals e to the y minus 1. So y is just on one side. And note that all terms without y are on the other side. That means we will be able to solve for y now. And since it's e, then you know that the inverse is ln, or logarithm base e. In other words, you just take the logarithm of both sides, natural logarithm, ln, and the effect would be to, okay, cancel out the e. Remember, ln and e are inverse functions, ln x and e to the x. If you still remember this one, ln e to the x is x, and also e to the ln x is x. One and thus the other. So if you look at the right-hand side, this is just the exponent. So it becomes y minus 1. And now you can solve for y. Obviously, you transpose 1, you'll get 1 plus ln x minus 5. And you call that your f inverse of x. And that's it for these kinds of questions. So for letter G, I want to do one where you are given ln. How do you get the inverse? Anyway, you can pause the video once I've uploaded it. You can watch it and then pause. So don't worry if I erased the solution for letter E. So letter G. Now F and H are similar to what I've done and to what I will be doing. So let's do that. Y equals ln negative x minus 1. We interchange x and y. All y will become x and all x will become y. And since we have ln on the right-hand side, we know the inverse of a natural logarithm is the natural exponential. So we raise both sides to e, or e to both of the quantities on both sides of the equation. So if I raise e to this, it will be the same as raising e to this, since they are equal. So e to the x equals e to the ln negative y minus 1. And the effect would be to again cancel out e and ln, so that the right-hand side is simply negative y minus 1. But no cancellation will happen on the left-hand side, since it's only e. Okay? And notice that the y is now below, so we will be able to directly solve for it. So transposing this, we get y equals negative e to the x minus 1. Okay, transpose this. So call that f inverse of x and you're done. Is there any question again? Okay, let's proceed. Find the domain and range of each function. We'll do 2 items here. Let me start with letter A. I'll do an e to the x and then an ln x. Now, first recall the following. For the function f of x equals e to the x, the domain is R. It's defined for whatever value of x you have. And then the range is set of all positive real numbers. So it's neither zero nor negative. It's always positive strictly. Now for the inverse function, which we'll just denote by ln x, f of x, the domain and range will interchange. Remember, that's the property of inverses. The domain of one is the range of the other, and the range of one is the domain of the other. But anyway, just bear in mind that the domain of the ln function or any other logarithmic function is the set of positive numbers. The ln is not defined for negative values or zero. ln 0 is not defined. Although the logarithm of negative numbers is complex. Now, the range of the ln, if you still remember the sketch, includes all real numbers from negative infinity to infinity. So, R. So, nagbalit lang sila. Pansinin nyo. Okay? The domain of one is the range of the other and vice versa. So, with those, we can do some of the items here. Letter A, y equals 2e to the x plus 1. Now, what is the domain? Set of all permissible values of x. And obviously, since this is just an exponential function, then quickly you can give the domain as R. So the real challenge here is to find the range. And actually, you can quickly write it down by noting that this is always positive. right? E to the x is always positive. So that means if you add 1, the range will be 1 to infinity. Okay, did you see that? But to be more accurate or formal, let's do it by solving for the inverse. If we want to find the range of 1, we can find the domain of the inverse, right? So if we find the domain, we switch x and y. Find the inverse first. We solve for y here. We get, okay, e to the y, note x minus 1 over 2. Transpose 1, then divide by 2. And then you solve for y, get the ln of both sides. And note that ln and e cancel out. So the left-hand side is just y. Now, to get the range of this, we need the domain of this. So ano yung domain nito? You look at x. What are the permissible values of x? Now, note that that's ln, so anything inside ln must be greater than 0. So all you have to do is solve the inequality x minus 1 over 2 greater than 0. And obviously, that gives you x greater than 1. If you multiply both sides by 2, the sense of the inequality will not change since you're multiplying by a positive, so x is greater than 1. So domain is 1, infinity. And that should be obvious since this is always non-negative or always strictly positive. Okay? If you can see it this way, then you can just quickly answer it or pick among the choices. Let's do one more on this. Any question? Let me see. Okay, none. So letter C. So domain. Ln. What are the permissible values of x? That's ln x. So it's only defined for greater than 0. Whatever inside ln, you set it greater than 0. So in other words, the domain is just 0 to infinity. Okay, by the way, I'll be doing one more after this. And then range. Well, if you just observe, this is ln x, and ln x ranges from negative infinity to infinity. So obviously, this quantity or this function will also range from negative infinity to infinity. So it's also r. But to see that more clearly, we solve for the inverse. So let's interchange and solve for y. So notice you'll get ln y. If you solve for ln y, x plus 1 over 5. Just verify that later. You can just pause the video. Now, raise both to e to both. The left-hand side becomes y. Of course, you can skip this step and proceed directly to this step. And you'll get this one for the inverse. Now, the range of the function is the domain of its inverse. So we just find the domain of this. And what's the domain? Set of all permissible values of x. And notice that you can plug in any value for x since it's e to the something. And that something does not contain a radical or a divisor of 0. That's always divided by 5. This one here. So the range is also R. And again, as I have stated, we know that the range of ln x is negative infinity to infinity. So if you multiply by 5 and subtract 1, it will still cover all real values. And then let me just do letter D. This one here. Now for the domain, you have to look at the permissible values of x, and there's x plus 4 inside. Of course, if this were a different expression, you would have to solve a different inequality, but this is very simple. So you just have to solve x plus 4 strictly greater than 0. So x greater than negative 4. And so the domain would be negative 4 to infinity. And then the range, same thing. Solve for y in terms of x. So interchange. Solve for y. Raise both or e to both sides of the equation. And n and e cancel each other out. And you can get the inverse as e to the x plus 2 over 2 minus 4. This is the inverse now. And the range of the function is the domain of its inverse. And the domain would be the permissible values of x. And again, it's R. It's not always R, okay? It depends on this one. If that contains square root or over x plus 1, something like a divisor, then you would have to take those into consideration. So is there any question on problems like this? Let's proceed then to number 3. I've given exercises, answered exercises like this in the 3A set of exercises. But this time it involves ln and e. So let's just do 2 here. So let's do A. This is very simple. If you look at A, think of f and g, outer and inner functions, whose composition is e to the 2x plus 1. And the most obvious functions are f of x. There's other functions, really. There are an infinite number of combinations. By the way, these type of exercises are given you so that you will have no problem in calculus. Since in calculus, well, anyway, when you go to the chain rule, you need to be able to think of a function as a composition. So I can define f of x simply to be e to the x, and g of x equals to x plus 1. And note that if I compose the two, f of g of x is, remember, you replace x by g. So you input this one into the x here, and you'll get e to the 2x plus 1, which is the one given there. So let me just do one more. Let's look at C. Let me give two possible answers here. One is obviously the 5 times, it's 5 times this, ln of that. So I can just define f of x equals 5 ln of something, or ln x. And that something there is my g of x. And note that if I compose the two, f of g of x, you plug in this one into x, you'll get the one given there. That is a correct answer. There are other correct answers. And to find another one, what we can do is simply apply the properties where we can raise 5 as an exponent inside the logarithm. Remember that? So please review the videos. So there, you can bring down 5 to get back to the previous one. It comes from the property that, by the way, ln, or more generally, logarithm base a of, let's say, a to the m equals m logarithm a, capital A base a. You can drop the exponent. So proceeding, we can define f of x as simply ln x, the outer function. And then the inner function as this one, the inner one there. And you'll come up with the same composition. Okay? Compose f of g of x is ln 1 minus 2x cubed to the 5. You put that one there. What's the question? Okay, next, and I think last set. Okay, let me do 4 or maybe 5 on this. So let's start with letter A. Here you are just to solve for the indicated variable. So for letter A, you are to solve for m. So isolate m on one side. So transposing, we get n plus 3 equals e to the m plus 1. And take ln. Let me just show the details, then later on, we'll just skip that step. So ln left-hand side equals ln right-hand side. And then we apply the properties of inverses. You get this, m plus 1. And then solve for m. And you're done. Okay? And then let's do letter C. Is there any question? So this time we use e. So that's ln. We raise e to both. E and ln cancel out. And then to solve for x, we square both sides. And then we multiply the exponents. An exponent within an exponent. So you multiply. E to the 2y. Then the radical disappears. Then you can solve for x. And you're done. Okay, next. Letter G. We do 2 more. Okay, this and the next. So there you are to solve for t. By the way, take note of the variable you are to solve for. Here you need the properties like multiplication is converted to addition and division is converted to subtraction. So to solve for t, okay, let me just take this approach. You can actually divide by t first, but just to illustrate the properties, okay, let me take the ln of both sides. If I do that, the left-hand side is just a single term, so it's just ln b, but the right-hand side is a product. So remember, multiplication is converted to addition. So this becomes, right-hand side becomes ln p plus ln1 plus r over m to the mt. And then what I can do from here is transpose and then bring this down, properties. So transposing, and then bringing down, and then I can solve for t by division. So I get t equals ln b minus ln p over m ln1 plus r over m. Okay? So is there any question before our last? Sige, last na. Let's do letter I. So solve for x. For this, you can just first cross multiply. So multiplying this one, these two, and then this by 1. That's y over 1. So we just e to the x plus 1. Then you're solving for x, so you combine all terms with x on one side. First, you need to distribute the y. Then those with x on one side, those without on the other side. So transposing this. So note that all terms without x are on the right-hand side, all terms with x on the left-hand side, which enables us to solve for x. So factor out e to the x to get this. And then isolate x again. And then you can apply ln. You can go directly to the last step though. Just x. Okay, so that's it for today. And study well, be prepared for the quiz on Friday. Okay? Just wait for further announcements from me if there is any. Okay. So I'll be ending now. All right. Okay, 3, 2, 1.